Hello and welcome back, students. So today we are going to start with another chapter of chemistry, which is going to be very interesting. So before we begin with the chapter, let's first try one experiment. So here I have one iron nail and a copper sulfate solution with me. Okay, so what is copper sulfate solution? It is CuSO4, right? And the color of copper sulfate is blue. So if I dip this iron nail, so basically the reaction between copper sulfate and iron is going to take place, and then we are going to observe that what happens when I add iron into this copper sulfate. So, okay, now we keep it for some hours, and then we will notice that there will be a significant color change, which we have already discussed in our theory, that there will be a displacement reaction taking place, as we know that iron is more reactive than copper, and hence it will displace copper from copper sulfate solution and it will form iron sulfate, which is of green color. So let's see. Whoa! What just happened? One moment we had a iron nail and blue color solution of copper sulfate, and now we have green color solution, and also we have copper deposited on the iron nail. This is the magic of chemical reaction. From the fizz present in your soda to the fuel that powers rockets, there is chemical reaction everywhere. And it is so interesting to understand how these reactions take place. So in this coming series of your chemical reaction chapter, we are going to break down what are physical changes and chemical changes, how we can alter the rate of reaction, either we can speed them up or we can slow them down. Okay, so I hope you are ready to dive in this very interesting chapter which is coming, which is your chemical reaction. Let's dive in it. So students, before we dive into this chapter, let's understand what all topics we are going to cover in this first part of your chapter. So one is physical changes and chemical changes. In this we are going to talk about what are physical changes, what are chemical changes, what is the difference between the two, and what are the examples. Then we'll talk about a very important theory in chemistry, which is collision theory. Then we'll discuss how do we increase the number of successful collision for us to speed up the reaction, okay, or to increase the rate of reaction. So let's dive into it with the first topic being your physical reaction or physical changes. So what is a physical change? Physical change is a type of process which can be reversed easily. For example, if you have a piece of paper and you crumble it, you can again get the paper in a similar way back, right? Another example is if you dissolve salt into water, you can separate them again and you can reverse the process by getting salt and water separately by evaporating the water, right? So this is what physical change is, in which no new chemical substance is formed. So let's read the definition. Physical change do not produce any new substance. And what about chemical changes? Chemical change is the type of change in which a new chemical substance is formed. For example, burning of wood will get you ashes, okay, and this is irreversible. Ashes cannot be converted back to the wood, right? So this is a type of chemical change, right? Next is physical changes are often easy to reverse, as we talked about the paper and the salt and water. Next is relatively easy to separate. They can be easily separated. Okay, next is example of physical changes. Let's discuss few example of physical changes. For example, if you have ice, which is solid form of water, you can convert this into liquid and you can convert the liquid back to the ice, right, by changing the temperature. So this is a physical change because no new chemical substance is formed. Okay, only the state is changing from solid to liquid and from liquid back to the solid. Okay, next is making a mixture from two or more substance. Now, what is a mixture? In your previous chapters, we discussed about what are mixtures, what are compounds. So, in that, we talked about the difference between the mixture and compound, which is in compound, the two elements or two molecules combine chemically, right? And they cannot be separated. Whereas in mixture, two or more substance are mixed together, but they are not chemically combined together. Okay, so they can be separated. So, a mixture of two or more substance are or it is an example of a physical change, because if you mix, like for example, if you mix rice and stones or pebbles, then you can separate them, right, and no new chemical substance is formed. It is just a mixture. Two different entities are added to get nothing new. Okay, you can also separate them easily. Next is dissolving a solute in a solvent. For example, if you add salt and water, then you can separate them also, right? And you are not getting anything new. A new chemical substance is not what we are getting, right? So this is going to be your example of your physical change. Also, few images are here for us to understand in better. So this is very easy. If you wish to note this down, you may do so. All right, I hope you have written this. Now let's move on to the chemical changes. We have already discussed a little about chemical change. Now let's talk about it. Chemical change involves the formation of new substance with different chemical composition. Okay, so if I'm adding two different type of molecules and if they combine chemically together to give a new chemical substance, then that is known as your chemical change. In a chemical reaction, a new chemical substance are produced and they have characteristics that are totally different from the original one, right? For example, if you are adding A and B and you get a product P, okay, so the properties of A and B are different than the properties of P, right? The characteristics are totally different. The characteristics of the reactants are not retained, and hence you get a new chemical substance which is known as product, and this reaction is not reversible and the P cannot be, or A and B cannot be separated again, okay, or I can say that we cannot get A and B again from this P, right? So this is a type of chemical change. For example, rusting of iron, okay, in corrosion, the topic corrosion, we study rusting of iron, wherein rust or the depletion of metal takes place when a metal is present in the presence of oxygen or air or moisture and water, and then it get depleted. It can get flaky or brittle, and the particles, the brown, reddish brown color of that iron, that of rust is formed. So rusting of iron is a chemical change. This cannot be reversed. Next is, if you try to burn wood, you will get ashes. Then you cannot reverse this reaction. You cannot get wood back from the ashes. Next is rotting of fruits, or I can say rancidity. This is also an example of your chemical change, because a new chemical compound has been formed and you cannot get back to the new one or to the old one. Okay, so let's read the example. Burning wood, rusting of iron, rotting of foods. Unlike physical change, most chemical changes cannot be reversed, okay, to return to the original reactant, because they involve the formation of new substance with different chemical composition. This is what I was talking about. If you wish to note this, you may do so. Okay, now let's understand how do we know if the reaction has taken place or not. So here are 5 characteristics of chemical reaction which will give us a hint that a chemical reaction has occurred. Okay, so the first one is change in state. If the change in state has taken place, like from solid to liquid or liquid to gas, then we can say that a chemical reaction has taken place. For example, if we convert water into your vapors, then it is a reaction. Okay, next is your formation of precipitate. If in any reaction a solid, or I can say solid insoluble curdy mass, which is also known as precipitate, has formed, then we can say that a chemical reaction has taken place. So what is a precipitate? Let me write down over here. It is insoluble curdy mass. Okay, so it is insoluble, hence the state symbol which we use over here is solid, right? It is an example of a reaction of precipitation, or I can say precipitation reaction, in which when we add silver nitrate to sodium chloride, we get a white colored precipitate of silver chloride along with that sodium nitrate, right? Another thing or another characteristic which will give us a hint that a reaction has taken place is the change in color. If we add two substance and it changes the color of the previous substance, then we can say that a chemical reaction has taken place. For example, if I add iron into your copper sulfate, which is blue in color, so what happens? Iron being more reactive than copper, it will displace copper and FeSO4 will be formed, which is green in color. So in this reaction, you can say that color is changing from blue to green, because CuSO4 is converting after reacting from Fe, it is converting to form FeSO4, and Cu will separate out. Okay, So this type of reaction we can understand very well if we have reactivity series with us, and I have also shared the mnemonic. So in the reactivity series, the one which is more reactive will displace the one which is less reactive, right? So if color change takes place, we can say a chemical reaction has occurred. Next is your evolution of gas. If any gas is evolved during a chemical reaction, so you can then say that a reaction has taken place. For example, Zn plus HCl. If you will react zinc with hydrochloric acid, which is your strong acid, you will get ZnCl2 zinc chloride. Along with that, hydrogen gases evolved. So this is a chemical reaction. Next and the last is change in temperature. So if the temperature of the test tube increases or decreases, or I can say the test tube becomes hotter or cool, then we can say that the heat has been transferred from system to surrounding or from surrounding to system. These reactions are exothermic and endothermic reaction. We have already in detail we have discussed this in the previous slides or in the previous chapter. So you know this part very well, right? So any of these 5 takes place, you can say that a chemical reaction has taken place. If the change in state or formation of precipitate, change in color, evolution of gas, or change in temperature has occurred, or you can see, then you can say that the reaction has taken place. Now if you wish to note down this, you may do so. Okay, now let's move on to understand what is collision theory. This is very important. As the name suggests, collision, it means for a reaction or for the reactants to form products, those reactants have to collide. Okay, so one thing is that the particles of the reactants have to collide. Now, it is not necessary that if particles are colliding with each other, they will convert into product. No, there are 2 options. Either the collision will be successful or it will be unsuccessful collision. So if successful collision takes place, then we can say that reactants will be converted into product or new substance will be formed, which is product. But if unsuccessful collision has taken place, then we can say that product will not be formed. Now how will we know if the collision is successful or not? If the particles have the minimum energy for the collision, that minimum energy is known as your activation energy. So if the particles have the enough energy to collide, the minimum energy for collision, which is your activation energy, then only that collision will be termed as your successful collision, and hence the reactants will be rearranged and converted into product. Right, so let's read this quickly. What is collision theory? Collision theory states that in order for a reaction to occur, means for the reactants to convert into product. Okay, so the particles must collide with each other. We have already written, okay, they must collide. Second, the collision must have sufficient energy to cause a reaction, that is enough energy to break bonds. Right, so that sufficient energy, the minimum energy that colliding particle must have to react, is known as your activation energy. This is very important. Okay, so if the particles have this enough energy, which is activation energy, then if they collide, then that will convert into product, right? Or then only the reaction will take place. Now, collision can be described as successful or unsuccessful. Let's see, a successful collision means that the reactant particles collide and rearrange to form products, okay? And unsuccessful collision is, this happens when the particles have sufficient energy. Okay, so what is successful collision? When they collide and the reactants convert into product. And why does this happen? Because the particles have sufficient energy, or I can say they have the activation energy, right? And what about unsuccessful collision? The unsuccessful collision means that the reactant particle just bounce off each other and remain unchanged. Okay, remain unchanged means the reactant particle will not produce products, they will remain reactants only. Okay, no chemical changes will take place. This happens when the particles do not have sufficient energy to break the necessary bonds or do not collide in the correct orientation. Okay, so 2 very important things from here we can say, that the particles collide, okay, but collision itself will not help. One, they should have the minimum energy, which is known as your activation energy. In short, I can write it like this. Okay, so they should have this minimum energy, which is known as activation energy. And second, they should have correct orientation. Okay, orientation also is very important. Correct orientation is very important for the reactants to convert into product, okay, for the particles to collide, okay. Now let's talk about the 3 possible scenario which can take place when 2 particles collide, okay. So first is, so if they collide but not with enough energy, it means if they colliding but they do not have sufficient energy, which is your activation energy, then what happens? Then the reaction will not take place, okay, then the reaction will not occur. If the particles have enough energy but they do not collide, now they are having their activation energies but they are not colliding only, then the reaction will not occur. Why? Because if they are not colliding, collision is necessary for a reaction to take place. So if they are not colliding, it means no reaction will take place. Next, and the third is, so if they collide but with enough energy, if they are colliding with the enough energy, then the reaction will take place, and hence these blue and green, which are different reactants, they will collide to form a product, okay, which is different, which have different identity, right? So these are the 3 cases which can take place. If you wish to note this part, then you may do so. All right, I hope you have noted this. These are very important points for your collision theory. So you should know that particles collide to convert into product, or for the reaction to proceed, collision should take place. 2 very important things. Particles should have the minimum energy, which is known as your activation energy, and another point is orientation. Okay, they should have correct orientation for the collision, right? Only then the reaction will move further. Next is your how to increase the number of successful collision. Now I told you that it is not necessary that every collision will end up into forming products, okay. If the particles are not having sufficient energy, then we can say that they have collided but it is not, like, the reaction will not proceed, or we can say this is a type of unsuccessful collision. But how do we increase the rate of the successful collision? So here we are going to discuss that. The number of successful collision depends on, now the first point is the number of particles per unit volume. We are going to discuss each of these points in detail in the coming slides. So the number of particles per unit volume, then the frequency of collision. The more the frequency of collision, the more the chances of successful collision, right? The kinetic energy of the particles, and then the activation energy. So these are the 4 points. This is a summary of the upcoming slides. So these are the 4 points which we are going to discuss now. Now the first being the number of particles per unit volume, right? So if you have, for example, beaker number 1 and beaker number 2, the beaker in which the number of particles are greater, or I can say the concentration of reactant is greater, or the number of reactant or particles are greater, more are the chances of their colliding, right? For example, over here only these are colliding, okay. Now this can be this can result into successful collision also, or unsuccessful collision also, and in this case, because the number of particles is greater in this particular beaker, so more number of collision will take place. They can be either successful or unsuccessful, but in comparison we can say that concentration really matters. If we increase the number of particles, or if we increase the concentration of the reactant, then the chances of getting successful collision is more. Okay, increasing the pressure of a gas increases the rate of reaction. Increasing the pressure means that there are the same number of reactants and particles in a smaller vessel. This causes more collision per second. For example, if you have this vessel, okay, initially the piston is over here, the particles are, for example, 5, but they are far apart from each other, okay. Now what I do, if I push the piston, or I can say if I'm applying the pressure, and the piston is now over here, the number of particles remain the same, which is 5, but now they are in smaller space. The number of particles remains the same, but here they are now smaller space, so there is more chance of them colliding with each other, right? So if we increase the pressure, this is what they are saying here, if we are increasing the pressure and the number of the particles remain the same, but in smaller volume, then also this causes more collision per second, leading to more frequent and successful collision per second. Therefore, the rate of the reaction increases. Rate of the reaction increases means speed of the reaction increases. It will now be, the reaction will take place faster, okay, or it will take less time for reactants to convert into product. If you wish to note this, please. Okay, now let's move on to the second point, how we can increase the number of collisions. So frequency of collision between particles. Now here, the more collision there are between reactant particles, greater the chances that they will collide with enough energy to undergo. So more the number of particles, more the chances of, or more the frequency of their collision, and hence the rate of reaction will increase. As if the collision is taking place at greater number, it means more chance of reactants to have successful collision and thereby getting rate of reaction to be higher. Okay, next is your how increasing temperature affects rate. Okay, if we increase temperature, what happens? We are increasing the thermal energy of the system. Thermal energy, right? Thermal energy increases. So the particles absorb this thermal energy, convert this into kinetic energy, which I am writing KE over here. Kinetic energy will be increased. If the kinetic energy will increase, it means the motion will increase and they will collide faster, right? Collision rate will increase. And hence the reaction rate or the rate of reaction will also increase. So this is a flow chart. If you wish to note down, you may do so. If you increase the temperature, thermal energy increases, particles absorb this thermal energy, can convert it into kinetic energy. Kinetic energy helps them to move faster. If they move faster, they will collide more. If they will collide more, the frequency of the collision increases. Therefore, more chance of having successful collision and thereby increasing the rate of reaction or increasing the chance of the reactants converting into products. Okay, so increasing the temperature increases the rate of reaction. Increasing the temperature means that the particles have more kinetic energy. Okay, this causes more collision per second, leading to more frequent and successful collision per second. The effect of temperature. Okay, from the diagrams you can see that after we have increased temperature, this is, let's say, T1, T2 being higher than T1, what is happening? They are moving faster. Okay, the rate of the collision increases and here hence they are resulting into more number of collision, hence the possibility of the reactants converting into products is higher. So please note down. Okay, now let's discuss the fourth point, which is your activation energy. So what was activation energy again? Activation energy is the minimum amount of energy or the sufficient energy which is required for the particles to collide and hence to proceed with the reaction, right? So activation energy is the minimum amount of energy required for a reaction to occur. So how does a catalyst work over here? So for example, this is the reactant, this is the product, this is energy profile diagram wherein on the x-axis reaction coordinates are given and on the y-axis energy. Okay, so reactant energy is greater than the product energy in this particular, this is an example of exothermic reaction. So what happens if we add a catalyst? It will provide us with a path in which the activation energy is lower. Okay, so a new path will be introduced after adding a catalyst. See, this is lesser, this distance is lesser. Okay, let's say this is x and this distance is y. So what does a catalyst do? Catalyst do not take part in a reaction, but it will just provide a new pathway which is shorter, hence increasing the rate of reaction. Okay, I am repeating once again, catalysts do not take part in a reaction chemically, but it will provide a different pathway or a shorter pathway for a reaction to take place, thereby increasing the rate of reaction. The reaction will occur faster if we add a catalyst. Okay, so catalysts are substances which speed up the rate of reaction without themselves being altered or consumed. So they are not taking part in the reaction chemically, but they are just providing a different pathway. Next is different process require different type of catalyst, but they all work on the same principle. What is the principle? That they are giving a new pathway with a shorter time to travel from reactant to product, right? A catalyst provides a different reaction pathway that has a lower activation energy. See, this activation energy, let's erase this. Okay, so this EA1, which is of catalyst, when we use a catalyst, and this is EA2, let's suppose. So this EA1 is shorter, right? So after adding a catalyst, what happens? This means a higher proportion of the reactant particles have energy greater than the activation energy and will result in more successful collision. So this EA1 is what? A catalyst provides a different reaction pathway that has lower activation energy. EA1 is lower activation energy, right? EA1 is in which catalyst is added, right? So this is a very important diagram to explain what really catalysts do to a reaction. Please make a note of it. Right, so here we come to an end of the part 1 of chemical reactions. I hope this helped you to understand the concepts really well. If you have any doubt, feel free to comment down below and I'll get back to you. And I'll be seeing you in the next video, which is coming really soon. So stay tuned. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.